Hello everyone and welcome back to Canal Sidings for a slightly different video from the usual. It's still railways, but it's actually about signalling. My new railway, I want to be able to actually have colour light signals that work. My previous layouts have never had any signalling at all, whether they were supposed to be semaphore or colour light. So what I decided to do some time ago, and you've already seen these signals before, because I showed them in my 2017 Christmas video. I just purchased them from the Far East, from China I think, and I got 5 of them for about £12, which is a damn sight cheaper than you can buy anything from the big manufacturers. They're not perfect, but they'll do. They will suit me okay. They're close enough to being right that I'm not too worried about them. So what I've been looking at is how to control them. Now, strangely, they are all common anode. They are positive common, not negative common like most of the British and American made signals are. That means that all the LEDs are returned to the positive rail. They have their anodes connected together, not their cathodes. And what that means is you need negative voltage to drive them. You need a low to drive them rather than a high, which is fair enough. I'm quite happy with that. And I've looked at the various ways that what you can buy to drive them with, and everything's quite expensive, and most things don't actually drive them. They can't handle the common anode. Heathcote's electronics versions of the boards can handle the common anode. You can order them common anode or common cathode, but they only drive, each one of their boards drives one signal and costs, I think, about 15 quid. So if I'm going to have 20 signals, that's going to be a hell of a lot of money. I need to do better than that. So what I decided to try ages ago was a good old Arduino, which is what you see sitting here. Now, I don't know if anybody knows Arduinos. It's just a little microcontroller on a board with all the pins brought out and the ability to connect a programmer to it. That's not the normal one, the normal Arduino that you see, which I forgot to pick up. I'll get one. That is the more normal Arduino that we see, which is an Arduino Uno. It says Uno on the back just about. This is actually what's known as a Funduino. It's an Arduino clone, which is perfectly reasonable, perfectly acceptable, perfectly legal. Arduino always made the whole thing completely open to anybody who wanted to use it, and this is one of the clones. But as you can see, compared to the size of that, this is enormous. And it won't actually do any more than that does, apart from the fact that here it has the ability to program directly from a USB connection. But that's neither here nor there. I have here a cable with a USB programmer, and you don't have to leave it connected permanently. Once you've programmed the device, then you can remove that USB programmer by just unplugging it from here. The device retains the program and everything works. Right, I'm not going to talk any more about programming, so don't get the idea that I'm going to talk to you about how you program Arduinos, because I'm not. If you want to do it yourself, then there's plenty of online resources. Go to the Arduino main website. But what I'm talking about is signalling. And what I have got here is not exactly a prototype, but a proof of concept, if you like, of what I can actually do with one of those tiny Arduino boards. And if you look around, we've got the Arduino board. There's a few connections, and the signals are all connected here and here and around there. These thin wires all come from the signals. And I have 3 push buttons here, which obviously won't be push buttons on the railway. They will be sensors in the track to sense a passing train. Other than that, I've got the resistors for the signals, which are on the ends of the common signal wires. They're 1K resistors. I think they could be even bigger, because the signals are very bright. That's about all I've got, really. There are no other components in there. The Arduino is driving everything directly. The Arduino runs off of 5 volts. At the moment it's running off of the USB power supply. It shows you how little it takes, even driving the LEDs. But the idea would be to run it off its own power supply, and because the USB won't be there all the time. So that is what we've got. But what have I tried to do? What do I want to achieve with it? Well, what I want to achieve is a semi-automatic signalling system that gives a convincing representation of the absolute block signalling system as it exists on the railway in the latter part of the 20th and this now 21st century. And that consists of colour light signals, which generally sit green, and when a train passes one, it goes red, and the previous signal goes to yellow, and the previous signal to that, if they are 3 aspect signals, which I've got, goes to green. There are 4 aspect signals with 2 yellows. I'm not going to bother with those, and the Arduino will struggle more with 4 aspect signals, because it's got there's another line to drive, and we are quite short of IOs on the Arduino. So what I did to start with was I wired up the 3 signals to the Arduino and wrote a simple piece of code, which each signal is totally separate in its own right. And basically what I've done is I have got within the Arduino I've got 3 signals, and I've got IO pins on the Arduino that allow me to have an output from this one back to that one as an input, and an output from this one back to that one as an input, and an output from this one and an input to that one. And what I've done is I've connected this output back to this input. That is what, if I can find it, this green wire here is, and we'll be taking that off soon. So what does it do? Well, these are the sensors. When a train passes, I'll try and do this so you can see what I'm doing. When a train passes, that sensor gets tripped and the signals change. The train is still passing, so the sensor's still tripped. Right, the train has now passed the sensor. The first signal is red, and the previous signal, remember I've wired this back to here, the previous signal has gone yellow. Okay, the train proceeds on its way and arrives at the next signal. It goes red. The previous signal goes yellow, and the one in front of that goes back to green. And then the train continues on to the last signal in the row, passes the sensor, that signal goes red, the other one behind it goes yellow, the last one goes green, and then it travels round the continuous run and eventually arrives back here and does the same again. That signal goes red, the previous signal goes yellow, and that one goes green. And that can continue forever. The train can go round and round. Of course, these signals are far too close together, but as the train goes round and round, the signals appear to work magically as if the train is being signalled around the layout. That was the basis of what I wanted to achieve, and I've achieved it with that little Arduino. Unfortunately, having done that, I've used every IO pin on the device, because you need 3 pins to drive each signal's LEDs, that's 9. You need 2 more pins for the inputs and the outputs between the signals, that's 2 per signal, that's another 6, that's 15. And you need inputs from the sensors, that's 1 per signal, another 3, that's 18. You haven't got any more space. You've got, on the Arduino, you have got 11 I/O pins and 6 dedicated inputs. 6 and 11 is 19. We are out of pins. We have completely run out of pins. Wow. I think I counted that right. Anyway, I can assure you there are no pins left to do anything with. So, where are we now then? Well, that's good, and it works for a very simple roundy layout. You could have 2 lots of signals, 1 in each direction, completely independent of one another. You could have a train running in each direction. Whatever speeds they're running, the signals will follow the trains. So, good start with one Arduino. And that Arduino, by the way, cost me £2.90 from a UK source. So they're not expensive. You could buy about 5 of those for the price of a Heathcote driver for 1 signal. I'm not knocking Heathcote. I think that what they provide is brilliant for people who are not prepared to do what I'm doing. But I'm looking for something that I can do myself. Okay, so what's missing then? What else do we need? Well, what about if you had the situation where you had a fiddle yard at this end, or a storage area, and a storage area at this end, and you wanted the trains to come out of one into the other. Well, the first thing you need to do is sever the connection between that signal and that signal, which I can do quite easily by pulling out, get the right wire, that one. I have now severed the connection. I'll just reset it so we can start again. That's just resetting the Arduino. So now we come out of the fiddle yard there, passing that signal. We get to the next signal and we pass it. That one goes yellow. We get to the last signal in our case and we pass it, and that one goes red. And we're now in the receiving end fiddle yard. Oh dear, that signal is now stuck at red, and there is nothing to remove the red from the signal. What do we do? Well, we could put another signal in the fiddle yard such that when it gets passed, this one goes red, sorry, amber, and this one goes green, and then another signal in the fiddle yard, but the result is always going to be the same. The last signal is always going to be red. So what I've done is, and it should be on a pin on the Arduino. You should be able to ground a pin on the Arduino and choose the method that I'm going to come up with, but I've run out of I/O. So I'm going to put a new program into the Arduino. It's not going to be that difficult. I'm just going to do it now. All the lights will go out in a minute, and you'll see a blue light flash down here, I think. No, you can't see it. I'll lift it up. There'll be a flashing blue light there. I'm not sure. I've got my finger in the way, actually. Sorry, you couldn't see that. There is a blue light on that, but it's not quite in frame, I don't think. Anyway, we've now reloaded, and we're back at the start with another, with the Arduino programmed differently, which could be done with a link. It doesn't have to be reprogrammed in reality. So we come out of that fiddle yard, and we pass that signal, and it goes red. And we pass that signal, and that one goes amber. Then we pass the last signal, and that one goes amber, and now we wait. And magically, the signals have gone back to green. And all I've done is actually put in what I call a termination timer. That is, when the last signal is passed, a timer is used to gradually set it back through from red through yellow to green. And now you can run another train, passing all the signals, and when it gets there, that signal will eventually go back. The timings are completely adjustable and will be pretty much dependent upon the layout, I would think, but and that probably isn't going to be available to change. I don't think it's going to be possible because not enough pins. Because there aren't enough pins. But that is a big improvement, and actually would not only work for an end-to-end layout, but it would work for a roundy with the fiddle yard here. So you come off this signal and you come into the fiddle yard here, and then you come back out to this signal. You don't want that one connected to that one because there's a whole area of railway over here which you can't see. So that's what I've been doing for quite some time, since the weekend. Today's Tuesday, so I've been poking about with the Arduino and poking about with the signals, and I think what I've got is a very good basis. What I have decided is that in order to do everything that I want to do with the signals, that the Arduino won't control 3, it's likely to control 2. And each one of those will be available with or without a termination timer. So you'll be able to choose whether they have a termination timer running or not after them. And they will have all the interconnections available for other signals. And there's one other thing. What happens if that signal's red, okay, because the train has passed it, but it hasn't left the other section yet, because say that signal's red. I can't make it red at the moment, but let's say that signal's red as well. Now that signal is red. If a train passes this yellow signal, it has to stop at that red one. But how do I do that? I can't do that. I can't make 2 signals red. It won't go. I can get them all green again. Get them all green. But when that one's red, that one won't stay red. It keeps going back to yellow because of the logic that drives it. So I've got to come up with a way of being able to make that signal go red and stay red, even if the previous one is red. Basically, the only way I can think of doing it is to have another input that forces that signal to go to red. It unconditionally forces it. Obviously any signal in front will go yellow, but it unconditionally forces that signal to red. There are other conditions for that as well. If there was a point here, like a crossover, that when set would derail a train, that signal has got to be red, even though a train hasn't passed it. The point has been set against it. And that requires a force to red or set unconditionally to red input to the signal. So there's an input there for each signal that we haven't got. You can see I'm really struggling for I/O now. So what I'm expecting to do is have 2 signals maximum per Arduino, and have all the features built in such that they will work. There is something else that I want to be able to do as well. We're talking about a single direction track here where trains only run one way. there are tracks that are bidirectional, lots of them nowadays, and they are signals for bidirectional running. I'm not really well up on what that looks like, but I would imagine there's a set of signals for each direction. And when a train is running east to west, then the west to east signals are all red, I would think. But I'm not sure about that. I need to try and find some more information. Anybody who's got any information about, or can point me in the direction of how single track bidirectional running works nowadays in terms of signalling, would be great. Anyway, that is as far as I've got with signals. Before anybody asks me in the comments, when I have a working Arduino and I can write some instructions for it, then I will be perfectly happy to let anyone have copies of the software. At the moment it's not workable yet, so the software is not available, but I will make it available. Basically, just ask me in the comment, leave me an email address. Just ask me in the YouTube comment and tell me you've sent me a private message with your email address on it, and I will email you a copy of the code and a copy of the instructions as to what connects to where. If you can't program the Arduino yourself and you want programmed versions, then I'm not sure. I don't really want to become a retailer for programming, but we can talk about it. To be honest, programming Arduinos is not difficult. Sorry, downloading the program to an Arduino is not difficult. You need a USB cable and one of these little boards and a driver in the PC, and you then need the Arduino software, which you load the source code into as a sketch. You load that into the software by file, sketchbook, find the file's name, click on it, it opens, and you then click one. Having got everything connected, you click one button on the Arduino IDE and it compiles it and downloads it for you. You don't have to know any more than that. I can demonstrate that for anybody who wants to do it that way. To be honest, where you buy these at the moment, I'm not sure. I'm sure they're available from China. This is a Chinese copy. I know because it's got a Chinese IC here that is made in China, designed and built in China. So I know that they are available from China. You can get them through Chinese eBay suppliers. You can get them through AliExpress. You can also buy the Arduinos, these. This is an Arduino Pro Mini, as opposed to the big one that I showed you earlier, which was that one, which was the Arduino Uno. You don't need one of these with an Arduino Uno because it's built in, but these are significantly more expensive. Anyway, that's all I've got to say about signals. There's one other thing that I have played with while my wife was waiting to go into hospital. She actually went into hospital last Wednesday. It's Tuesday today, and she's had her gallbladder out, and she's now allowed to eat anything. She's still got to be careful about the fact that she has just had an operation, so she's not allowed to drive for about a week. She's going to try today, but I have tried to persuade her not to, but she's adamant that she can never go today, so fair enough. And she also has got to go and have the stitches out on tomorrow. No, not tomorrow. Thursday, 2 days away. She had it laparoscopically, i.e. keyhole surgery, but she's got 3 holes in her stomach. She looks like she's been shot 3 times. they're a little bit painful round the hole, and she's a little bit bruised, but you know, she's doing fine. And I'm trying to help her out, so I haven't been doing very much here, just a bits here and there. Anyway, one other thing, as I say, that I have been playing with, that you also seen in a previous video, was Hornby Class 86s, and I have one now with 2 motors in it and no traction tyres, and I'm just going to give you a demonstration of how well or badly that works. So I'll be back soon. Okay, we're back at the railway now. Here's the Class 86 with 2 motor bogies. It has significant problems because the 2 motor bogies, it is DCC, and the 2 motor bogies are not matched. They are both 3-pole, but they just don't match one another, and it is not happy. However, what we're interested in is what's its hauling power. So let's pick some coaches up and see. I'm just taking it round to pick up my rake of beg your pardon, got that the wrong way round. Pick up my rake of Mark 3s. Here it comes now. And it's capable of going much more slowly now that it's well loaded. And this is a Class 86 with 2 motor bogies without any traction tyres. And it is now pulling, you may have counted them, but there are actually 7 coaches. Oh, that's a dirty bit of track, I think. That's just pulled 7 coaches past there. Now, I have actually tried it and pulled a lot more. I'll just bring it round again, and I'll put a couple more coaches on, and we'll see how well it can do. Just coming round again. I'll pass the camera in a second, because I've got to get it far enough that it will stop at that point. Okay, you see it's a very jerky stopping and starting. Just added a few more coaches, so we now have the original 7, the 7th one just coming round now, Mark 3s, there it is, followed by 1, 2, 3, 4, 5 Mark 2s and a DVT. And that, as I say, is a Class 86, a Hornby Class 86 with no traction tyres. I think we can say that haulage wise it's brilliant. However, its ability to run isn't so good, and its problems are mostly down to the fact that the 2 motor bogies don't match. They fight one another, and you can see it on the rolling road where they can run at any speed they like. One of them starts long before the other, and then the other one chirps in a bit later, and you can see that will make running jerky. I know what to do. It needs 2 decoders, 1 for each motor. It'll be fine then. If the motor's matched, 1 decoder would work, but you can't set you can't set back EMF on, because it really is upset then, in that the two motors, there's a dirty bit of track up there, the two motors tend to fight one another, producing the back EMF. And the loco is completely confused, and as I say, you could see that on the rolling road with the cover off. But I'm going to put two identical decoders in it, and I can then set them up differently for the two different motors. And this is where we come to yet another feature of some of the cheap decoders I use. It was available on the Hatton's decoders and available on all the Lay's DCC decoders, and that is a feature called decoder locking, whereby you can set two decoders to the same address but lock them independently so that you can't change CVs, not CDs, you can't change CVs. And when you want to change a CV on the motor, what you have to do is unlock one or the other of the decoders and then change the CV, and it won't affect the other one. So for instance, you can set stop and start voltage to be the same. You can set start voltage, I beg your pardon, to be the same, mid voltage to be the same, top voltage to be the same. They will both have independent back EMF, which you can turn off independently at different times as well. So that will be a great advantage. There's definitely some problems with the dirty track over there. Haven't run the railway for ages, so it'll take a little while. That loco, by the way, is running up speed step 10. I've now just put it up to speed step 20, so you'll see it coming round a little faster than it was. Not a lot, but a little bit. Anyway, that's all I'm going to show you from my Class 86s at the moment. When I've got two decoders in it, I'll show you what I do to set the two decoders up independently, and I'll tell you about this decoder locking feature, which means you can set both of them with the same address but control the CVs independently. That's all I've got for you this time. Hopefully I can start soon to produce my videos a little closer together, but I'm not going to promise anything because I've tried that before and failed miserably. So until next time, thanks for watching and goodbye.